Good day, learners. Today we will discuss about chemical bonding. The world around us is composed almost entirely of compounds and mixtures of compounds. Rocks, coal, soil, petroleum, trees, and even us. Human beings are all complex mixtures of chemical compounds in which different kinds of atoms are bound together. The manner in which atoms are bound together has a profound effect on the chemical and physical properties of substances. For example, both graphite and diamond are composed solely of carbon atoms. However, graphite is a soft, slippery material used in pencils, and diamond is one of the hardest materials known, valuable both as gemstone and industrial cutting tools. The question is, why do these materials, both composed of solely of carbon atoms, have such different properties? The answer lies in different ways in which the carbon atoms are bound to each other in these substances. Molecular bonding and structure play the central role in determining the course of chemical reaction, many of which are vital to our survival. To understand the behavior of natural materials, we must understand the nature of chemical bonding and the factors that control the structures of compounds. In this lesson, we will present various classes of compounds that illustrate the different types of bonds. We will then develop models to describe the structure and bonding that characterize the materials found in nature with its respective properties. Now what is a chemical bond? Although there are several possible ways to answer this question, we will define a bond as a force that holds groups of two or more atoms together and makes them function as a unit. For example, in water, the fundamental unit is hydrogen, oxygen, and hydrogen molecule, which we describe as being held together by two oxygen and hydrogen bonds. When solid sodium chloride is dissolved in water, the resulting solution conducts electricity, a fact that convinces chemists that sodium chloride is composed of sodium and chlorine ions. Thus, when sodium and chlorine react to form sodium chloride, electrons are transferred from the sodium atoms to the chlorine atoms to form sodium and chlorine ions, which then aggregate to form solid sodium chloride. The resulting solid sodium chloride is a very sturdy material. It has a melting point of approximately 800 degrees Celsius. The strong bonding forces present in sodium chloride result from the attraction among the closely packed, oppositely charged ions. This is an example of ionic bonding. Ionic substances are formed when an atom that loses electrons relatively easily reacts with an atom that has high affinity for electrons. In other words, an ionic compound results when a metal reacts with a non-metal. So these are some common ionic compounds and their uses. Sodium chloride, or NaCl. It is used in food preparation, manufacture of chlorine and sodium hydroxide. Cobalt chloride, known as silica gel, which absorbs water. Another is potassium iodide, or Ki. Iodide supplement in iodide soil. Next is silver nitrate for antiseptic and germicide. Sodium nitrate, used for meat preservation additive. Aluminum chloride, used in deodorants. And potassium nitrate, used in gunpowder, matches, and fireworks. This illustration shows the formation of bond between two hydrogen atoms. Let us explore this situation by considering what happens when two hydrogen atoms are brought close together, as shown in figure 3a. When hydrogen atoms are close together, the two electrons are simultaneously attracted to both nuclei. Note in this figure how the electron probability increases between the two nuclei, indicating that the electrons are shared by the two nuclei. The type of bonding we encounter in the hydrogen molecule and many other molecules where electrons are shared by nuclei is called covalent bonding. Note that in the hydrogen molecule, the electrons reside primarily in the space between the two nuclei, where they are attracted simultaneously by both protons. When we say that a bond is formed between the hydrogen atoms, we mean that the hydrogen molecule is more stable than two separated hydrogen atoms by a certain quantity of bond energy. A bond like this is called non-polar covalent bond, or simply a covalent bond. In cases where the two atoms involved in the covalent bond are not the same, then the attraction is not equal. The bonding electrons are pulled more toward the atom with a greater attraction, more electronegative atom. So this bond is a polar covalent bond. The atom that has the greater attraction takes on a partial negative charge and the other atom a partial positive charge. We see in the previous section that when a metal and a non-metal react, one or more electrons are transferred from the metal to the non-metal to give ionic bonding. On the other hand, two identical atoms react to form a covalent bond in which electrons are shared equally. We can also distinguish a bond based on its properties. But how do you know if a compound is ionic or covalent by just looking at a sample? This is where the properties of ionic and covalent compounds can be useful. Because there are exceptions. You need to look at several properties to determine whether a sample is ionic or covalent. But here are some characteristics to consider. This is the comparison chart of properties. So the basis for comparison first is existence. In ionic bond, it exists in the solid state only, while in covalent bond, it exists as solid, liquids, and gases. It occurs between in ionic bond in non-metal and metal. In covalent bond, it occurs between two non-metals. In conductivity, it is the measure of the ease at which an electric charge or heat can pass through a material. In ionic bond, the conductivity is low, while in covalent bond, the conductivity is very low. In terms of hardness, hardness is the resistance of a material to the formation of an indenture of a specific size and shape under a known load. In ionic bond, these are hard because of the crystalline nature, while in covalent bond, these are not very hard, though exceptions are silicon, diamond, and carbon. How about the melting points and boiling points? The boiling point is the temperature at which a material changes from a liquid to a gas, while the melting point is the temperature at which a material changes from a solid to a liquid. Keep in mind that the material's melting point is the same as its freezing point. In ionic bonding, the melting point is high. In covalent bonding, the melting point is low. In malleability, malleability is the state of being shaped, as by hammering or pressing into sheet. In ionic bonding, these are non-malleable, while in covalent bonding, these are non-malleable. In terms of ductility, ductility is the capacity to undergo a change of physical form without breaking. In ionic bonding, it is non-ductile, and in covalent bonding, it is also non-ductile. So in terms of volatility, when you see volatility or volatility, the tendency of a substance to evaporate at a normal temperature. So in ionic bonding, the volatility is low, and in covalent bonding, the volatility is high. And then last one is solubility. So in terms of solubility, when you see solubility is a property referring to the ability of a given substance, the solute, to dissolve in a solvent. In ionic bonding, it is usually insoluble in water but soluble in organic solvents such as ether, alcohol, benzene, tetrachloromethane, propanone, and other. While in covalent bonding, it is usually soluble in water but insoluble in organic solvents such as ether, alcohol, benzene, tetrachloromethane, propanone, and other. The next table shows the melting and boiling points of some ionic compounds. As you can see, the melting point of calcium oxide is 2580 and the boiling point is 2850. In magnesium chloride, the melting point is 714 degrees Celsius and the boiling point is 1412. Sodium chloride, the melting point is 993 and the boiling point is 1695. In aluminum oxide, the melting point is 2030 and the boiling point is 2970. And lastly, the sodium chloride, the melting point is 801 and the boiling point is 1420. A lot of heat energy is needed to break the strong ionic bonds during melting point or boiling. Hence, ionic compounds have high melting and boiling points with low volatility. After we discussed all about chemical bonding, so what you will do now is you will going to match the definition in column A with the correct terms in column B. Write your answer in a separate sheet of paper. So I will give you at least 5 minutes to answer this learning task number 1.
Okay, let us check your answer for your learning task number 1. Number 1, letter C, ductility. Number 2, letter G, hardness. Number 3, letter F, ionic bond. Number 4, letter B, conductivity. And number 5, letter D, solubility.
Okay, class, that's all for today. Thank you and see you in our next lesson.